All right, everybody, we're ready to get started. How's everyone doing today? Good, good. Welcome to the Morrison Planetarium. My name is Mary. I use she and her pronouns. I'm going to be your presenter today for our tour of the universe. And just curious, how many of you saw a planetarium show earlier today? Nobody? That's fine. How many of you didn't see a planetarium show earlier today have seen one of our planetarium shows before? Okay, a few of you. So this is one of my favorite shows that we do here in the Morrison Planetarium because most of the shows that we do during the day are pre-recorded movies, kind of, with a short section where a presenter can talk to you about a particular news item. This show is completely live, so I'm going to be our pilot as we fly through the universe today. We're going to start out at Earth, see how far we can get out into space, and I'll take us safely home at the end of the show. And if anybody has any questions after the show, feel free to swing by the pilot's booth, which is where I will be hanging out at the very top of the room. But in order for us to get started, I do have to head all the way up the stairs to said pilot's booth. And on my way up, I have a few quick planetarium rules to go over. First of all, please no eating or drinking while you're in the planetarium today. If you did bring in any food or drink, just make sure it stays sealed and put away. While you're following that first rule, the next rule should be pretty easy. Please make sure to keep your mask on for the entire show and make sure that it's on all the way. If you have a cell phone, a camera, a tablet, anything at all that could give off light or sound, both of those can be very distracting in here, so we want to make sure that those are all put away during the whole show. And for your safety in this dark theater and with these very steep stairs we have here, we do highly recommend staying seated throughout the entire show. But if you find that you need to leave early for whatever reason, the exits are at the top of the stairs on either side. Just know that once you leave, you won't be able to get back in. And last but not least, this can create a very immersive experience. So if at any point throughout the show you feel any dizziness, any motion sensitivity, just go ahead and close your eyes for a few seconds, and that will help your brain remember that you're just sitting in a chair in a planetarium, not actually flying around in space. So without further ado, go ahead and sit back, relax, give me just a few moments to get into our pilot's booth, and we will get started. All right, so we are starting our tour of the universe today, relatively close to home, just a few hundred miles above the Earth's surface, here at the International Space Station. And I always like to start out my tours at the International Space Station because it gives us just a little bit of perspective on how incredibly far we're going to travel today. Because today we're going to see vast distances. We're going to see things like how far have human beings traveled out into space? How far have our spacecraft traveled? How far has anything that we've sent out into space traveled? And we are going to go much farther than that today. But the farthest that humans do physically travel right now is to the International Space Station. Like I said, just a few hundred miles above the Earth's surface, orbiting our planet very quickly. It only takes them about 90 minutes to go around our planet once. And I'll bring up a yellow line so we can keep track of where the International Space Station's orbit is. So you can see that line is showing us where it goes around our Earth. And people have been living up on the International Space Station for quite a while now. You can fit about 6 astronauts in it at any one time. And the longest that any one particular person has lived up there was about a year. And people have lived up there for about 20 years, but don't worry. It's not just a bunch of the same 6 people stuck up there for 20 years. They swap out every few months usually. And as we zoom away, we are seeing the current location of the International Space Station. And something I want to point out about this entire show is that everything we're going to see is based on actual pictures or actual data of the locations we are going to visit. Because today I'm using a software called OpenSpace, which is a free open source software that uses data from places like NASA and other space research institutions. And so the clouds that we're seeing around our planet, those are where those clouds were early this morning. So it updates every morning, think about 3 a.m. or something like that. But as much as I love our lovely home planet Earth, we're not going to stay here super long. And I'm not going to stay any one particular place super long throughout the show because we have a lot of distance to cover. I want to see if I can take us out to the farthest that we can see in the universe. So that takes a bit of time. So we're going to keep going at a pretty quick speed here. But our first stop as we go away from the Earth is our closest natural neighbor in space, the Moon. Now I'm going to focus on the Moon here, so sometimes that makes the screen move kind of quickly. So if this makes you dizzy, close your eyes for a couple of seconds. Oh, it actually wasn't too bad this time. Moon was in a good position. Well, we're going to fly over to the Moon, and I did say it's our closest natural neighbor because we have a lot of human-made satellites that are going around our planet. Things like space science satellites that study weather or how our tectonic plates move. The International Space Station you could think of as a human-made satellite as well. But the Moon is our natural satellite going around our planet and is the closest natural object out here. But even though the Moon is the closest object to us here in our solar system, it's still very far away. It's about 250,000 miles away from us. And this is also as far as humans have traveled so far. The Apollo astronauts came out here in the 1960s, and they walked around on the Moon's surface. It took them a couple of days to get to the Moon because it's so far away. And here at the Moon, which let me zoom in just a little bit more so we can see the lovely features it has, its craters and its dark maria that we're seeing here as well. But here at the Moon, I like to introduce an idea that I'm going to be using throughout the rest of the show. And that idea is the speed of light. So like I said, the Moon is our closest neighbor, but it's still about 250,000 miles away. And as we go out today, we're going to see distances of millions, billions, trillions, and even more miles and kilometers. So if I keep using miles or kilometers to tell you how far we are, pretty quick, at least for me, it's not going to make any sense. So from here on out, I'm going to use a different way to figure out our distance, and that's by using the speed of light. So if you can imagine traveling the fastest speed we know of in the entire universe, that's already hard to wrap your head around, but still, try to imagine you're traveling this incredible speed, the speed of light. If we were traveling that speed, it would have taken us 1.5 seconds to get to the Moon from Earth. So we say the Moon is 1.5 light seconds from our planet in distance. So the time to fly over to the Moon would have taken us roughly the same amount of time that it did here using OpenSpace. Not too much time at all. But as we zoom out, we can also see the orbit of the Moon. I'm going to bring that up in blue in just a moment. And I'll keep using these different blue lines to keep track of the objects that are in our solar system. So you can now see where the Moon goes around our planet Earth. And we're going to keep zooming out until we start to see the orbits of the other planets in our solar system as well. And for a moment, I'm going to focus on the very center of our solar system, the closest star to us, the Sun. So let's try to keep going with trying to wrap our heads around how far we're going. And we're going to think about how long it would take us to get to the Sun from Earth if we were traveling at the incredible speed of the speed of light. So if we were traveling from Earth to the Sun, it would have taken us about 8 minutes or so to get to the Sun from Earth. So the Sun is 8 light minutes away from us. There's a couple of different ways I like to think about that. One thing is that if the Sun just disappeared for some reason, we wouldn't know about it for about 8 minutes. Thankfully, though, there's no reason why that would happen. Don't worry. Another way I like to think about it is that if you walk outside and if you look at the Sun, first of all, that is very bad for your eyes. Never ever look at the Sun. But if you did look at the Sun, that's what it looked like 8.5 minutes ago, not how it looks right now. So within these few light minutes of distance, we're also seeing the orbits of these smaller rocky planets in our solar system. Closest to the Sun is Mercury. And then as we go out, we see Venus, Mars, And then farther out still, we see Jupiter, Saturn, Uranus, and Neptune. And for our last Wednesday of the month lately, we've decided for our tours of the universe, we're going to pick some favorite object or location to visit. And so today, I've picked an object that is really far out in our solar system, right about where we are right now. But before I get to that, I do want to point out one location of objects that we did pass by as we went from the inner rocky, smaller planets closer to the sun out to the bigger, gassier planets, Jupiter, Saturn, Uranus, and Neptune. Because in between Mars and Jupiter, there is a pretty sizable gap there that we saw, but that is not totally empty space. That is where we find most of the asteroids in our solar system. So most of the smaller rocky objects, give it a second, the asteroid, there it is. So we can see the asteroid belt in between Mars and Jupiter. And we couldn't see it before because asteroids are pretty small compared to the other planets and things that we have in our solar system. So they're not reflecting a lot of light. So in order for me to show them to you, I had to make them much, much brighter than normal. But the object that I wanted to highlight today is out here past the orbit of Neptune, my favorite dwarf planet, Pluto. Now, working in the planetarium, I get people asking me about lots of different things when it comes to space. But Pluto is one that I often do get questions about. People are curious about Pluto. They want to know, why is it not a planet? Did it get kicked out of the solar system? Did it explode? What happened to Pluto? And why do I hate Pluto? But I'm here to tell you, I do not hate Pluto. I think it's very interesting and a very cool place. And we're going to learn a bit about it today. So Pluto is way out here in the solar system, out in something we call the Kuiper belt. So similar to how I highlighted the objects in the asteroid belts in between Mars and Jupiter, I'm now going to show you where there are some other objects very far out in the solar system too. Give it a second as it loads. There we go. And these are what we call Trans-Neptunian objects, meaning that they orbit beyond the orbit of Neptune for the most part. And if you take a look at these, some of them have these kind of wild orbits going above or below the plane of the solar system. But if you take a look at where most of these are orbiting, they kind of make a belt similar to the asteroid belt, but much farther out by Pluto. Now, we did not know that any of these objects were out here until the late 90s and early 2000s. And as astronomers were finding more and more of these objects, which I'm going to turn them off for now because they make it a little jittery. But as they were finding more and more of those objects, mostly small, icy objects, a few of them were around the size of Pluto. So as astronomers were finding more and more of these objects as we got better telescopes in the late 90s and early 2000s, that brought up an idea or a conundrum, I guess you might say. Should we call these bigger objects that are around the size of Pluto, should we call them planets as well? Or is there a different name for these objects that we should be giving them? So back in 2006, a group of astronomers got together and put this up to a vote. Should Pluto remain a planet? And they voted that no, it would not remain a planet because it is inside of the Kuiper belt out here. Because one of the requirements that they decided on for a planet is that a planet needs to have cleared its path. It must have a cleared out orbit. Now, a lot of people were upset about this, and I understand that because Pluto was a very familiar place to a lot of people as it being a planet and not this other object called a dwarf planet, which a lot of people hadn't even heard of because that was a new category of objects in the first place. But I like to think of this as a great change because there's an object in the asteroid belt that for a long time was just called an asteroid, even though it used to be called a planet. And it was kind of forgotten for a while. But now Ceres, which is in the asteroid belt, is a dwarf planet along with Pluto. So I think it's a great story about just how we learn more about the universe as we explore and how science works. We got to change things up as we learn more and as we discover more objects out there in the universe. But all that to say for whether or not Pluto is a planet, I also think it's a little bit beside the point because either way, Pluto is a very interesting place. So we're zooming into Pluto so we can get a nice close-up look at it because it is one of my favorite places in the solar system and a place that we did not know much about until just a few years ago. Because Pluto is really far out in the solar system. It would have taken us several hours to get out here if we were traveling at the speed of light. And back in 2015, we sent a spacecraft by Pluto. The New Horizons spacecraft flew extremely close and took some very nice high-resolution images of Pluto for us. So before that, we didn't know much about Pluto. We thought it just looked like this kind of weird brownish blob. We didn't know if it was rocky. We didn't know if it was icy. It was a pretty mysterious place. But when New Horizons flew by, it discovered a lot of amazing things about Pluto. For instance, here on this side of Pluto, you can see this big white area that is sometimes called the heart of Pluto, because if you look at the really white area, but also the area next to it to the right over there, looks kind of like a heart shape on Pluto's surface. And this is an area of nitrogen ice and also some water ice and stuff as well. And if we take a really close look, you can see that it has some texture to it. It almost looks like there's cracks in the ice. And that's showing us things that are going on underneath the surface. This white, snowy-ish looking area, this nitrogen ice, might have a consistency similar to toothpaste because it's moving around a little bit, because we think there might be a slushy ocean or lake underneath the surface of Pluto. So that's pretty interesting. We didn't know that until just a few years ago. And as you look around the surface of Pluto, we're seeing mountains. It has mountains of water ice. It also has nitrogen snow, which I think is pretty interesting. And it has a very thin atmosphere that sometimes looks really blue, which is kind of cool too. And if you look to our left a little bit, you can also see Pluto's biggest companion. It has 5 moons, the biggest of which is named Charon or Charon, depending on who you talk to. And this moon, I would argue, is what we should actually be arguing about when it comes to naming things in our solar system, because I don't think it should be called a moon at all. I think this should be called a binary dwarf planet system, because Pluto and Charon orbit each other. Charon does not orbit Pluto because it's pretty big compared to how big Pluto is. So they're kind of like this, doing this little dance around each other as they rotate in our solar system. And I think that's pretty cool. But we've spent a lot of time over here by Pluto, so I'm going to zoom us back out so we can see Pluto's orbit once again and the orbits of the other planets in our solar system. We're going to keep on our journey, our tour farther out into space. And I mentioned New Horizons, that spacecraft that flew by Pluto just a few years ago. Something I learned today is that New Horizons took a picture of one of the other spacecraft that is really far out here in the solar system. It took a picture of Voyager 1. So I'm going to bring up the trajectories, the paths that the farthest spacecraft are taking in our solar system. Give me just a second. There we go. So let's reorient ourselves a little bit and think about how far we've gone out into space so far. So these yellow lines we're going to see here, these are showing us how far the 5 farthest spacecraft we have sent out have gone. So if you remember from earlier, we visited the moon. The closest neighbor we have in space would have taken us about 1.5 seconds if we were traveling at the speed of light to get there, and is the farthest that humans have traveled. Now we're seeing how far our spacecraft have traveled. And if we go back to imagining us traveling at the speed of light, even though these are the farthest and some of the fastest spacecraft, and they've been going for a while, the earliest of these were sent out in the 1970s, none of these 5 have gone as far as light can travel in a day yet. So we're still only out to a few light hours of distance way out here by our spacecraft. And real quick, as I zoom away from them, the names of these ones are New Horizons, Voyager 1 and 2, and Pioneer 10 and 11. So the farthest spacecraft that we have sent out so far. And as we zoom away, we're getting into kind of a gray area of, are we in our solar system still? Have we left the solar system behind? But you'll notice that our sun is doing something interesting. It's changing its brightness, because before, the model of the sun that we were looking at was dimmed down quite a bit, so we could actually see the other things in our solar system a bit better. So now that we're farther away, we've put the sun model so that it is at its true brightness. So this is what it would look like if we were to travel this far away out in space. And as we keep zooming away, if you take a look around, you can notice that we are starting to fly past other stars in our galaxy. So once we get that far out and we start to fly past other stars, there's no question about it. We are outside of our solar system and we are in interstellar space, the space between stars. And let's check in really quick to see how far we've gone. So it would have taken us a few hours to fly out to our farthest spacecraft if we were traveling at the speed of light. If we were traveling at the speed of light and we wanted to visit another star, that would take us at least 4 years. The closest star to us out here is about 4 light years away. So things are extremely spread out here. There's a reason we call it space. There's a lot of space in between things as we go away from our solar system. And a really intriguing thing about a lot of the stars that we're looking at, these nearby stars that we are flying past, is that a very active area of research in astronomy is looking for planets that are outside of our solar system. So all of these blue markers, these are showing us where we have confirmed that there is a planet around another star. So far, we have found over 4,000 of what we call exoplanets, planets that orbit stars outside of our solar system. And we're finding more pretty often. There's a few telescopes that's one of their main things, is that they look for exoplanets. And many of these stars have multiple planets too, just like our solar system has multiple planets as well. But right around here, this is our last chance to check in with anything we've sent out into space. So we already saw how far our spacecraft have gone. So anything we're seeing from here on out is not because we've sent something there to take a picture. Everything we're seeing from here on out is because the light of that object traveled a very large distance, got into our telescopes, and we were able to capture an image or data of it that way. But there is one more thing that we have sent out into space, aside from our spacecraft and aside from us traveling as well, are radio signals. So this little blue sphere that I've just popped up is what we call the radio sphere. And this is how far any radio signals we've sent out, how far they could have gone. And the earliest radio signals that were strong enough to escape our planet were sent out roughly the 1930s. So this is about 90 light years away from us in all directions, because all those radio signals are traveling at the speed of light. And unless they run into something, they're just going to keep on going at the same speed that they started with. Since things are so spread out, running into things is very unlikely out here in space. As we zoom away from our radiosphere, I'm going to turn off our exoplanet markers, but I'm going to keep on the radiosphere because I like to keep an eye on it as we zoom farther away. And in a moment, our model of our galaxy is going to shift a little bit. You can kind of probably tell that it's starting to look a little bit different. Before, we were seeing images of what the Milky Way Galaxy, what our galaxy looks like if you were to see it in a really, really, really dark location and look up in the sky. But now we've switched it so that we're looking at a model of what we think our Milky Way Galaxy does look like if you were able to travel outside of it. Now, like I said earlier, we haven't sent anything out here this far. This is incredibly far away. So we have not snapped a picture of the outside of our galaxy from this view. But we can see a lot of our galaxy with the different telescopes that we do have. So we're able to map out what we think it would look like, even though this isn't a picture exactly of what it would look like. So our Milky Way Galaxy has billions and billions of stars. The sun is just one of them. And it is incredibly large. I'll give you a second, see if you can still spot the radiosphere. Can you see the radiosphere there? Near the top, that teeny tiny little blue dot right there. That is how far any of our radio signals have gone. Because our galaxy is thousands of light years across. If we were traveling at the speed of light, it would take us at least 100,000 years to travel from one side of the Milky Way to the other. But let's not stop there. There's a little bit farther we have to go. And if you look to our right, we actually just flew past a couple of dwarf galaxies that are going around our major galaxy, the Milky Way. And now we're looking at lots and lots of dots, which are no longer individual stars like we were seeing earlier. Instead, every single dot we're seeing here is a totally separate galaxy from our own. And every single one of those galaxies has its own billions or sometimes trillions of stars. And always like to point out the different colors of the galaxies that we are seeing here. And I'm sad to say these are not the actual colors of these galaxies. I think it would be fun if it was, that it would look like cosmic Skittles out there in the universe. But no, these different colors we're seeing are because of how we've mapped out these galaxies. So these are an actual map. We've seen where these galaxies are. We've looked at them with our telescopes, and we've mapped out where they are relative to us. And because this is a real map, in a moment, I'm going to rotate us around a little bit so we get a better angle. We'll see that there's kind of a strange shape that these galaxies seem to form. Looks sort of like an hourglass, or maybe a bow tie or a butterfly, or some people say it looks a little bit like pasta. But I am sad to say again, the universe does not look like a butterfly. That would be fun though. This shape that we're seeing of these galaxies is because we are looking at all of this from our perspective here on Earth. So the large gaps that we see on the top left and bottom right, those gaps aren't really there. We do think there are more galaxies over in those directions. But our Milky Way galaxy that we're living in has a lot of dust, has a lot of gas, it has a lot of stars, has a lot of stuff in it. And so when we try to look in those directions, that's looking in the same direction as the plane of our galaxy. So there's a lot of stuff in the way, makes it hard to see over in those directions. So there are even more galaxies than what we have mapped out here, but we just haven't been able to map them out quite yet. And let me pause real quick before we finish zooming out here, because I do want to check in with how far we've gone. So if you recall, let's see, so the Milky Way Galaxy would have taken us 100,000 years to go across. This far out, it would take us at least a few billion years, even if we were traveling at the speed of light. Which brings us to an important point as well, which is that all of this that we're looking at, this is looking at our universe how it was in the past. Because this light takes so long to travel here and get into our telescopes that by the time we see it, it's traveled for billions of years, and we're seeing what it looked like in the past. So, for example, if you think about the beginning of the show, when we looked at the sun, which again, never actually look at the sun, but if you looked at the sun, that's how it looked 8.5 minutes ago. Well, this is what our universe was like billions of years ago. And because of that, that means that we are about out of time here, and because we've gone almost as far as we can, because there is an edge to everything we can see and how far back in time we can look in our universe. And that edge of our observable universe, it's sometimes called, is all around us now, the cosmic microwave background, some of the first light that we're able to see and detect. Now, when you walk outside at night and you look up at the sky, you're not going to see this every single place you look. Thank goodness, that would scare me. But if you walked outside and you had microwave vision, if you were able to see microwave light, which is a lower energy form of light, you would see this everywhere you look in the sky. So this is some of the earliest light we can see, and I like to refer to it as the baby picture of our universe because it is so young in our universe's history. But since I can't take us any farther, we're going to wrap up really quick and we're going to fly on back home. Now, as we fly back home, keep in mind, if we were really this far out in space, and if we were really traveling at the speed of light, this journey would take us at least 13 billion years. But thankfully, we're in the planetarium. Should only take a minute. And one last thing I always like to think about as we're traveling on back home this vast distance is that all of this that we've been looking at, all of these stars, galaxies, planets, dwarf planets, asteroids, everything that we can see, that's a very small portion of what we know to be out there in the universe. There's some really mysterious things that we call dark matter and dark energy that we're still learning about today. Dark energy is some mysterious force that is causing space itself to accelerate as it expands. Dark matter is some mysterious substance that doesn't seem to interact with light, but we do see evidence of it, especially at the edge of galaxies. And we're still trying to figure out exactly what these things are, but we do know that they make up about 96% of our universe. So all of this that we can see is only a tiny, tiny percentage of everything we know to be out there. And that can make people feel rather small and uncomfortable. And I agree, I feel kind of uncomfortable with that idea sometimes myself. But another way I like to think of it is that, well, yes, we're this teeny tiny dot in this gigantic universe, but look at all of this that we have found so far, almost entirely by looking through telescopes. And that's pretty exciting that there's so much more to learn about and so much more to discover. But even so, once we get back to our radiosphere distance, back to our kind of human realm here in our galaxy, I do feel a little bit of comfort that we're heading back home. And we're going to head back to the third planet from the sun, the place where we've sent out all of these spacecraft into our solar system and beyond, and the only place where we have found life at all so far, which is pretty incredible to think about too. And we're back home. Hooray! So with that, I want to thank you all for joining me today for our tour of the universe. I hope you enjoyed flying around with space with me, and I hope you will all enjoy the rest of your day. Thanks for coming.